So single replacement reactions, again, are typically going to be just like the lab that you did, where you're adding a solid thing to a solution of something else, and then the things are going to switch places within it. Most of the ones that we're going to do are going to be cationic replacement, because most of the time we'll be dealing with putting a metal into a solution, and metals are always cations because they're on the left side of the periodic table. They have positive charges. So these reactions are also irreversible reactions. There's not really any way to undo what happened in your test tube, which is why you had to put it in the chemical graveyard, because I can't do anything with that stuff anymore. Okay? So the way that we predict whether or not something happened is by using the activity series, which again is in your reference packet. It turns out that actually sometimes a reaction won't happen. If you put a metal into a solution, it might not do something. And the activity series helps us figure out whether or not something would happen. You can actually predict whether or not something would happen. So it is literally a list of substances ranked in order of their reactivity. So the way that we read that is if the lone metal reactant is higher than the bonded metal reactant. The reaction will occur. Okay? So when you say aqueous solution, that means that it's an ionic compound that's been dissolved in water. So when we write states of matter after reactions, that's what this AQ here means. Okay, this S means solid, but AQ means specifically that that's hydrogen and chlorine ions dissolved in water. So that's why it's called hydrochloric acid. That's why it's an acid. Okay? So only the ions that are in solution can react or replace a piece of metal, and those are called dissociated ions. So it's DISSOCIATED, dissociated ions. So using the reaction that's up there, we have iron that we're putting into hydrochloric acid. Again, because it has the AQ after it, that's how you know that it's an acid and not hydrogen chloride, the molecule that we saw when we balanced equations the other day. The AQ indicates acid. And we're going to be making aqueous iron 2 chloride with hydrogen gas being released. So what do you think this reaction would look like if you have hydrogen gas being released? All right, so the way that this would look is we have essentially a little chunk of iron. So we have like literally a chunk of it. I'm just drawing an iron cube. It can be an iron nail if you'd like, whatever you want it to be. And then we have hydrochloric acid in a solution in the bottom. So remember that it has to be aqueous because the ions have to be dissociated. And what that means is that you literally have hydrogens and chlorine ions floating around. Okay? So those are supposed to be like 2 hydrogen ions, 2 chlorine ions. But they're just floating around in solution. They are not bonded together anymore. That's the important part. All right, so after this reaction happens, then we can consult the activity series to see whether or not this would occur. So we're looking for the lonely metal to be higher than the bonded thing. So basically on your list, what is your lonely metal in this reaction for the reactants? What's alone? The iron. So you're looking for iron to be higher than hydrogen. Is iron higher than hydrogen on your activity series list? So this reaction is possible because iron is higher than hydrogen. That's what that list tells you, basically. Okay, so because that's going to happen, then the iron and the hydrogen are going to switch places. And because you already told me that this is going to look bubbly because it's going to be a gas being released, then I'm going to have bubbles of H2. So I'm just going to draw bubbles. And that's ugly. H2 gas, okay, being released out. And now the iron is in solution. But because iron and chlorine make an ionic compound and it's still in solution, those ions are still dissociated. So now we have iron that has a 2+ charge and chlorines that are -1. Okay, so that's why the formula is FeCl2, because iron is +2 and chloride is still -1.